All right, we finally got the crank back from the machine shop for this 910 turbo motor we're building, and we had the journals polished and the crankshaft balanced with the flywheel and the clutch plate. That's all good to go. The mains on the crank all mic'd out at about 2.5, with number 5 being a little bit bigger. It's about a half a thou bigger. So they're all perfect. They're right where I want them to be. Put the bearings in, and our clearances are too large. So we're going to order some oversized bearings, and we're going to put them back in, and we're going to see if we can dial this in a little bit more. And that leads me to another topic, which how do I say? So that leads me to another topic, which I've thought about over the years. We all have heard the word blueprinted engine, right? And a lot of guys will throw that term around. And I really, if you drill down, I don't think people really understand what blueprinting an engine means. So I'm going to touch on that for a minute. Because do we blueprint engines at Westcam? Yeah, we kind of do. That's what we're doing here. We're dialing in these tolerances for the purpose of the engine. Okay, so blueprinting. Let's do an analogy. It's like if you want a new suit, you can go to a big box store, you can buy a suit off the rack, and it fits. Fits pretty good. Like I'm a 42 regular, and I put a suit on, and it looks pretty good. You know, it might be a little big in the waist, or have to be taken in some areas, but it fits okay. Now, the alternative is you go to a tailor, and the tailor is going to custom make that suit for your body, for a purpose, right? It's a specific purpose. So that suit is going to be blueprinted for you. There's not one solution to a blueprinted engine. The Lotus 910, if somebody says it's blueprinted, the conversation doesn't end there. You got to follow up with, what's it blueprinted for? How'd you set it up? And then that's when people start to glaze over a little bit. So I want to touch on that. When I talk about blueprinting a motor, really there's 4 main things that I focus on. One is the precision fitment of the different components, the bearings and all that, the clearances, consistency across components. Is everything balanced? Are all the rods within spec? How tightly are they balanced together? Third being balanced and aligned. Is everything aligned properly in the block? Is this thing set up the way it should be? And then finally, it's optimized for a purpose. The purpose can be different, right? It's a race engine. I'm going to optimize it for racing. It's a street car. I'm going to optimize it for street use. So, but what does that mean? How is that different? Okay, so let's break it down. If we talk precision fitment for street, I might go with tighter clearances because that's going to give me a quieter engine and a smoother operation. And longevity out of the motor. If we're talking about a race engine, I want to loosen up those tolerances for higher RPMs and oil flow and accommodate the thermal expansion that engine is going to be exposed to that a street engine would not. When we go to consistency across components, if it's a street engine, I want to ensure smooth operation, balance, and reliability. Again, that's what I'm after with the street engine. A race engine, I just want to prevent weak links under extreme stress and load, right? I want this thing to last. You hear about motors blowing up during races all the time. We want to get them as tight as we can, or built as well as we can so they operate at the highest performance. We don't really care so much about longevity, right? Number 3, the balance and alignment. For a street engine, we're doing this for improved refinement, drivability, and engine life. Now, if it's a race engine, we just want it to survive at high RPMs without failure. 2 totally different goals, right? And then finally, optimize for a purpose. And I think this one defines it the best. For a street car, we want to prioritize drivability, efficiency, and durability. That's what we're looking for. We want these motors to last and perform well for a long period of time. If it's a race engine, we're going to prioritize peak performance, cooling, and fast response, sometimes even at the cost of longevity. So we might not care We don't want the motor to last 5,000 miles. We want it to last this one race. We want it to last 500 miles, and that's it. So that's the difference. You can have a blueprinted motor, but you blueprint it for a purpose, and they can all be different, right? In this particular case, we're blueprinting for the street. So let's just talk about the main bearings, where we want to be. And before we do that, we have to know what kind of oil we're putting in this engine, because that plays a big part of knowing what our bearing clearances should be. So I love the Valvoline, the VR1 20W50. I think it's a fantastic oil. It's great for the tappet design of this engine, and it's a nice thick oil, and it gives us a lot of protection. So with that, and looking in the service manual for the 910 engine, it'll tell you that the bearing clearances need to be between 0.0005, half a thou, and 0.0022, just over 2 thou. It's a pretty big range, right? So that's not acceptable for blueprinting. We can't be at 0.005 on one journal and 0.022 on another and call it a blueprinted engine. There's too much difference between those, so we want to tighten that all up. So taking into consideration motor oil and the use of this motor, I want my bearing clearances, my main bearing clearances, to be between 0.0018 and 0.0020. That's going to give me the best of both worlds, and if I can keep it within those ranges, then I've got a motor that's more dialed in than when it left the Lotus factory in Hethel years ago. In this case, back in 1986. So are we blueprinting the motor? Yeah, because we're not going with that generic off-the-rack suit. We want a little tailored. We want to feel good. We want to tailor this thing. So that's what we're going to do. Now, we might run into some challenges. I measured all of these clearances, and a couple of them are out pretty far, and there's some significant differences. I think I was between 0.0024-ish, all the way up to 0.004 on some of these journals, which is not acceptable. It's way over tolerance. And if our oil gaps are too big, if our clearances and our bearings are too big, we'll have higher flow, but we'll have less film stability on that bearing. It's not going to retain the oil during startups and shutdowns. So that's bad. That's going to cut into longevity. We don't want that. On the other side of the equation, if we have too little clearance, 0.0005, in my opinion, too damn tight. I think we would risk starvation of oil at startup, right? It's so tight that I don't know that the oil is going to get in there and lubricate this thing at startup the way it should. So we want to find that sweet spot. And for this engine, 0.0018, 0.0020. Sometimes it can be tricky to get there. So a couple of tricks. In this case, the standard bearings were too small, even though the crank measured out stock, standard. So we are going to put in a set of 1 thou oversized bearings. We're going to measure again and see where we are. And if we don't get to where we are, if we're still like a half a thou too big in some places, you know what we could do? We can mix bearing shells. So we can use a 1 thou oversized half shell and a standard half shell. And that can fine tune us and dial us in a little closer to where we want to be. So that all goes into the blueprinting of the motor, right? We're trying to get within that spec, and we're going to do whatever we have to do machining-wise in strategically using different bearing shells. Remember, those same manufacturer. Don't mix up bearing shells from different manufacturers. They've got to be identical. But we can use those tricks to dial in and get exactly where we want to be. So just a little sidebar on blueprinting there, because it comes up in conversation, and I don't think a lot of people truly understand what it means and how it relates. And if they get a motor back from us, is it blueprinted? Is it not blueprinted? So I hope that helps a little bit. So that aside, we're going to continue on with this. We got to pull these bearings out. We got to put in the oversized bearings. We got to take all our bore measurements again and see where we are, and then we're going to play. Then we're going to see how close we can get these things. So I got to wait till I get some bearings. I thought I had some oversized bearings in stock. I don't. I've got 2 thou over, but I don't have 1 thou over. So we're going to wait a couple days and we'll jump back on this when we get those bearings, and we'll see where we're at. All right, but while we're waiting for the new bearings to come in, let me show you guys how I took the crank, measured the mains, and then took the bore gauge and measured the bore on the block. I'm going to show you my process, show you what I go through, show you how I get my measurements, and then when the new bearings come in, we get to do it all over again. Okay, I got the crankshaft back from the machine shop, had all the journals polished, and it's been balanced with the flywheel and the pressure plate. The rods were balanced. So what we're going to do today is measure the mains, measure the big ends on the crank, and then we're going to go ahead and take a look at the block and measure the bores and see what our clearances are on all the individual journals on the crankshaft with the bearings installed. Yeah, we're going to start down here with the number 1, go to the 2, go to the 3, go to the 4, go to the 5. 5 is typically just a little bit bigger than the 1 through 4, designed that way. And then the rods 1, 2, 3, 4, these should all be the same. So let's mic these out and see what we're dealing with. All right, we're going to start with the number 1 journal. And I've got my micrometer here. It's a 2 to 3 inch micrometer. I know these should spec out around 2.5, so it's the right micrometer to use. Before you do this, you want to make sure you calibrate this. This comes with the micrometer, so it is set correctly, and if not, you have a little adjustment tool. You can adjust it. I'm not going to go into that. There's plenty of videos on how to do that, but I have checked this one this morning, and it is calibrated properly, so I'm going to go ahead and measure journal number 1 and see how we do. And I like to get it snug, but it should still be able to fall off the journal with gravity. So you don't want it so tight that it's hung up on there. So try to find the perfect balance. Okay, that feels good. So if I let go of it right there, it's going to fall, but it's very snug on the journal. And I'll measure the center and the 2 sides. That's about perfect. And I've got exactly 2.50. That's perfect. 2.50 on number 1. I've been through these, and they're very consistent. Without even moving the micrometer setting, this has the perfect feel. It's snug, yet it can fall with gravity if I let it. Same with number 3. It's pretty consistent the whole way across the journal. Number 4 is spot on as well. Number 5 is just a hair tight, which is good. So our number 5 specs out at 2.5005. So really close to 2.5, just a hair bigger. So the mains all check out. We'll take a look at the manual spec sheet now, and you'll see that we are within spec. Let's pull that out and take a quick look. All right, so it's a 1986 turbo motor. If we're looking at the specs for the crankshaft, the main journals 1 through 4 should be between 2.4995, 2.5005. We're 2.50 on all of them. It's perfect. Number 5 should be 2.5 to 2.5005, and we are 2.50005, so we are good there as well. And they're kind of all on the larger side, which is really good because our clearances will be even tighter with the standard bearing setup. So let's go ahead and measure the bore inside the block now, and then we'll determine what our clearances are on each of the 5 journals. Okay, to get the clearances from the bores inside the block, we need to use a bore gauge, and we're going to take our micrometer that is set to 2.50. It's what the main's mic'd out at, and we're going to zero our bore gauge on that number. So I'm just going to pop this in, and my little handy dial, I'm going to turn that till I get 0. You want to rock it back and forth. Make sure you get the right setting. Okay, she's looking good. She's zeroed out at 2.50. All right, my main journal bearings are in the block. The cradle is torqued up to spec. I think it's 65 foot-pounds. My bore gauge is set to 2.5. So when I put it in here, the reading I get on my gauge, because this is set and zeroed at 2.5, the reading I get in here is going to be the clearance I have between the main journals on the crank and the bearings inside the block. So let's see what we get. All right, we're going to start down here with number 1. And I'm measuring from 6 o'clock to 12 o'clock. That's where I want to check my static clearance. And I'm going to rock it back and forth until that dial no longer moves. I want the smallest reading I get. So here I'm at like 2.5 thou on one side. When I say one side and the other, I'm doing the front side of the bearing, then I'm going over the oil groove, and I'm going to the other side of the bearing, and 2.5 thou. All right, so let's check the next one. Number 2 journal, I got 3 thou, and just over 3 thou. Go to the next one. Got about 2.5. Just over 2.5 thou. I'm going to go to number 4. It gets a little tricky. You got to put this bore gauge all the way in here and be creative with your hands. Let's see. And don't let it fall in the grooves. That'll really mess you up. It's got to be on the bearing. And stay out of the interface between the 2 bearings too, the seam where they come together. So on number 4, I'm 2.5 thou. And let's check number 5. Number 5, I am just over 3 thou. All right, so interestingly enough, the crank is perfect. It's never been ground. It's a stock crank. It's 2.5. It's like exact. These are all big. They're all out of spec. The maximum gap I should have is 0.0022, and I'm at like 2.5 thou or greater on all of these. So what does that tell me? It tells me either the line bore on the block wasn't correct from the factory, Or the line bore on the block, it could have been rebored. It could have reline bored it. I don't know. It's possible. I would suspect one of those two things. But regardless, and it's rare that you ever reline bore these. I've never had an engine where I've had to do that. They've always been pretty good. But regardless, so on this engine, we need some oversized bearings. So that's what we're going to have to do. We're going to have to get the 10 thou over bearings and go through this process again. We're going to be closer. We're going to be closer to where we want to be, but we might not be exactly where we need to be. So we'll probably get some 2 thou over bearings as well, which will give us a little wiggle room when we come back to this. We can split the shells and try to dial it in even tighter, because remember, we're going for a tight tolerance on this. So that's where we are right now. Unfortunately, we have to wait till we get these bearings in. I've got the 2 thou over, I don't have the 1 thou. So until then, that's about as far as we can take this block right now. We can't put the crank in, we can't do any of that. And you know what's interesting? It's at this part of the build, you're feeling really good because you got all the parts cleaned up, you're getting stuff back from the machine shop, and the natural tendency is to want to just put the motor together. But this is the most critical time to not just put the motor together, to take your time and to calibrate all of your measuring devices, take your time on the measurements, triple check them, make sure you are getting accurate measurements and you have repeatable measurements, which is very important. Don't just do it once. And if it's not correct, don't lie to yourself and say, it's close enough, and build the engine. If it's not correct and you can fix it, take the time to fix it. Because again, remember, we're kind of funneling in on blueprinting an engine here, and the purpose of this in a street car is longevity and smoothness. Those are the keys that we're after. To get there, you need to take the time, you need to pause at this point and make sure you do it right. And it's frustrating, I get it, because you probably bought the wrong bearings. And you're like, I just spent $250 on a set of bearings I can't use. Technically that shouldn't happen, because you can measure your old bearings and you can measure your crank before you send it off to the machine shop so you have an idea what to order. We do that as well. But there are cases where you order the bearings and they're just not correct. In this particular case, the bearings came with the engine, and so the first course of action for us was to put in the standard bearings and kind of see where we are. So that's how we ended up here, and unfortunately we just have to wait for those new bearings to come in. But no big deal. We'll pick it up in a couple days, and hopefully we're going to resolve these problems. We're going to dial in, we're going to get it just right, and then we can start to build the engine. Only then. This is the important time. You got to go through this. All right, that's it for now. Thanks for watching. Appreciate it. Subscribe. You know, it's always a good thing. And we'll see you next time. All right. See you.